Hello, everyone. Welcome to Unit 1, Lesson 6. You see it's perimeter and area, which should be review. However, we are going to add something to it. Of course, you probably could have expected that. I'm going to underline what I have here in the learning target, composite figures. You're going to see what that looks like on the back. Before we get to that, let's just make sure you understand perimeter and area. All right, so perimeter is the distance around a shape. It is a one-dimensional measurement, which is why the label is units, whatever the units are. This will make more sense once I talk about area. Area is how much space a shape covers. It's dependent on length and width, so it is a two-dimensional measurement, which is why the label is units squared. The units and labels are very important. Okay, perimeter and area, you should know these. They're on formula sheets, but just so you are aware, perimeter is 2L plus 2W, and the area is length times width. Other methods, or not methods, but other labels could be base and height. So length and width, base and height, they mean essentially the same thing for what we're talking about here. So find the perimeter and area of a rectangle with a base of 5 feet and a height of 54 inches. A lot of people are going to jump right in and say 2 times 5 plus 2 times 54 to get the perimeter. Problem is, one of them is in feet, one of the measurements is in feet, the other one is in inches. That's a problem. We want to change it. So what I'm going to do is I'm going to change feet into inches. So feet into inches, I'm going to multiply by 12 because there's 12 inches in 1 foot. So 60 inches. And I'm going to find the perimeter and area using that. So the perimeter would be 2 times 60 plus 2 times 54. And I get 120 plus 108, and I get 228 inches. Okay, the area was 60 times 54. Type that in your calculator, you should get 3,240, and the label here would be inches squared. Now, what happens if I wanted to put this in feet? Okay, let's change 54 inches into feet. Well, 54 divided by 12 is 4.5 feet. And now let's redo what we just did with these new measurements. So the perimeter would be 2 times 5 plus 2 times 4.5, which gives me 19 feet. Okay, the area would be 5 times 4.5, which gives me 22.5 feet squared. Okay, so pretty basic because it's just a basic rectangle, but making sure your labels match. That was the key of that question. Now we're going to get into a little more application. So a pool has dimensions that are 15 feet by 20 feet. The pool has a deck surrounding it that is 3 feet wide. How much would it cost to build a fence around this area if fencing is $12 per foot? So first thing I want you to see is where we're building this fence. So the fence is going around the whole thing. It would not make sense to put the fence here. Now your walkway is outside your fence and it does you no good. Plus you can't get out of your pool. Okay, so we're going around the gray rectangle. Well, we're putting fencing around it. We're looking at the perimeter. We want the distance around. We're on the perimeter here. So a lot of people are just going to go 20 plus 3 and say 23, and 15 plus 3 and say 18, and say 23 by 18. But that's not right, because if you're looking at the distance across, how many times do you add 3? Well, you add 3 here and here. So that's 15 plus 3 or plus 6 gives me 21 feet across. And then top to bottom, same thing. This is 3 feet, and so is this. So I'm doing 20 plus 3 or 6, and get 26 feet. So now I can find the perimeter with those dimensions. Just make sure you get the right dimensions. 2 times 21 plus 2 times 26. And I should get 94. So the perimeter was 94 feet. Now, that's not what I asked in the problem, though. The problem asked, how much would it cost if the fencing is $12 per foot? Okay, so if it's 94 feet and it's $12 per foot, I'm just going to do 94 times 12. And I get $1,128. Okay, so that would be the estimate before tax on that fence. Okay, how much did the concrete deck cost if the concrete cost $2.50 per square foot? So now we're looking at square footage, which is area. All right, so now we got to find the area of the concrete. Well, how do I do that? Well, that's going to be the area of the rectangle, the whole rectangle. But then you're going to take away the area of the pool because the pool didn't get covered in concrete. That would be weird. Okay, so we want to find the area of the rectangle and then subtract the area of the pool. And then what's left is the area of the concrete. So the area of the rectangle is 21 by 26, right? We just found those up here. Minus the area of the pool. Well, that we already know the dimensions of that. It's 15 by 20. So 21 times 26. 546 minus 15 times 20, I believe it's 300. Yes, it is. So subtract those two, you should get 246 square feet for the concrete. Now that's how much square footage there is. Now the cost is going to be, got to remember, multiply, right? 246 times $2.50. Which would be $615. You wouldn't have to put the 0.00, but I did. So there you go. That's an application of perimeter and area. Like I said, we're making it a little bit harder. Definitely within your ability, but a little bit harder. Now we're getting to composite figures. Composite figures is putting some figures together and finding the perimeter and area of those. All right, so with perimeter, the mistake I see the most is people missing sides. Okay. And maybe the other thing would be making the wrong, finding the wrong lengths. So right now, how many sides does this figure have? Well, it's got 1, 2, 3, 4, 5, 6. So I need to have 6 numbers here. Okay. I have this one missing and I have this one missing. So I've got a horizontal side and a vertical side missing. So the horizontal, what's the total distance across this figure from horizontal in the horizontal direction? Well, it's 15. So this whole thing is 15. But this portion right here is 4. So what's left? Well, 15 minus 4 is 11. That's segment addition postulate, which you learned back in lesson 3. So that part right there is 11. I'll go ahead and get rid of that. Okay. And now we'll look at the vertical. So the vertical total is 10. Well, I've already got 6 of that, right? So what's left is 4. All right, so the 2 vertical pieces, 4 and 6, need to add to 10, and they do. Okay, so now I've got my 2 missing sides. Perimeter should be as easy as just adding them all up. Now, here's what I do see some people do is they'll add too many sides or forget a side. So I like to mark where I'm starting. So I'll just start here. You can start anywhere, but I'm just going to start here and I'm going to go that way. So the perimeter is 11 plus 6 plus 4 plus 4 plus 15 plus 10. And I've reached that spot again and I am done. Just got to add them up. All right. So 11 plus 6 is 17. 4 plus 4 is 8. And 15 plus 10 is 25. 17 plus 8 is 25. 25 plus 25 is 50. So the perimeter here is 50 meters. Okay. Yeah, just making sure I did my math right. 17, 21, 25. Yep. Okay, we're good. The area can be done multiple different ways. I don't want to take a ton of time, but I do want to show you that there's multiple ways of doing this. Okay. The one that a lot of people are going to do is this one right here. They're going to cut that right there. And I'm going to find the area of both rectangles or squares. One's a rectangle, one's a square, and then add them. All right, so this box over here is 10 times 11 or 110. Okay. This box on the right is 4 by 4, so 16. So then 110 plus 16 is 126. So the area of this box is 126 meters squared. Now, let's say I did it a different way. I want to show you other ways as well. The other obvious one would be cut it here. Now I have 11 by 6, which is 66. And then I have 4 by 15, which is 60. And 66 plus 60 is also 126. Okay. Let me show you a third way. Some people do like this way better. Make it a full box. The area of the full box is 10 times 15. And then subtract, take out this box, which is 4 by 6. So that's 150 minus 24, which you probably guessed is 126. Okay. That's a pretty basic composite shape. Next one's a little bit more tricky. A lot of sides in this one. So let's get the missing sides first. Well, how many do I have? Well, I got one here and one here. Well, the horizontal is fully across as 10. I've got 2, I've got 3, and I've got 3. All horizontal, right? What's missing? 3 plus 3 is 6, plus 2 is 8. What's missing is 2, so this is 2. The vertical distance is a little bit harder to see, all right? In order to see it, I'm going to go ahead and clear everything, and I'm just going to put this as 2, because we just found that. The vertical distance is from here to here, which is 3 and 6, so that's 9. So I need it to be 9. I've got 3, I've got 3, that's 6. I need 3 more, so this is also 3. Okay, perimeter now. Make sure you mark this one because there's a lot of sides. So 3 plus 2 plus 3 plus 2 plus 3 plus 3 plus 6 plus 3 plus 3 plus 10. So how many 3s is that? 1, 2, 3, 4, 5. 6 3s. That's 18. I have 1, 2 2s, so that's 4, and then 6, and then 10. So 4 plus 6 is 10. 10 plus 10 is 20. 20 plus 18 is 38 centimeters. The area, I'm going to clear this because it's kind of messy. The area, I would say you'd want to split this however you want, as long as you can find the areas. I'm going to go here and here. Okay, so the top box is pretty easy. 3 times 3, that's 9. The bottom box is not as easy because I need to know that this right here. And that's the combination of 2 and 3, so that's 5. So 5 times 3 gives me 15. And the bottom one, 3 times 10, that one should be pretty easy, that's 30. Add those 3 areas up, that, and that. So 9 and 15 is 24. 24 and 30 is 54 centimeters squared. Okay. Could you have split it up differently? Absolutely. Okay. I'm not going to necessarily do the whole thing again, but I do want to show you that you could have split it here, 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 and done the same thing. Okay. That is perimeter and area. And that is the end of this video.